This video is intended to assist authorities having jurisdiction, like building inspectors and fire prevention officers, to debunk common misconceptions about mechanical duct fireproofing and to prevent errors in the use of the alternates process. There's a lot of marketing information by special interest groups in the public domain on this topic. Even ICCES has put out information that did not result in code acceptance of ISO 6944 or ASTM E2816. Why? Because of opposition at code hearings by three parties in particular, none of whom earn a living from duct fireproofing, and each of whom have an interest in public safety. So fasten your seatbelts, watch and listen carefully. You may find something that's completely in contradiction to some of the marketing that you've seen out there. Debunking ISO 6944 and ASTM E2816. Here we go.
The first thing that could be confusing is the terminology. Remember, after 3 it's a pattern. You will see this in the realm. Fire resistive. Sounds good, except that one must understand the test standard that this is based on, which you will if you watch this whole thing. If you are a building official who has granted the use of these standards, ISO 6944 and ASTM E2816, this may cause you to think again when you confirm the contents of this video against the text of these standards. Please presume I'm jiving you. Assume I am off my rocker certifiable and then buy the test standards and read for yourselves. Next terms here, HVAC, heating, ventilating, and air conditioning. In the trade, this is referred to as sheet metal work. Technicians doing the installations are sheet metal workers, and well-trained examples of these fine trades are organized in the Sheet Metal Workers Union, part of AFL-CIO. Sheet metal work is very broad, but unlike the nomenclature for ISO 6944 or ASTM E2816, the actual work of fireproofing ductwork is far narrower than all the sheet metal work that goes into a building. Why make it sound so broad? Because the hope on the part of special interests here is that more ducts will be fireproofed than the building code intends at the moment. Good for the economy, but not necessarily making even the remotest sense, and one may argue that this nomenclature could create the impression that what is being delivered is more capable than the actual test standard will let through in terms of approved products.
Building codes in the US and Canada call for the use of shafts to lead building services, including but not limited to mechanical ductwork through shafts, such as this one under construction here at the DuPont Canada headquarters back in 1986. The idea is that shaft walls pass the conditions of acceptance of ASTM E119 or its identical cousin standards, CAN ULCS 101 or UL 263, all the same. Building codes in Canada and in the United States, where it comes to qualifying criteria for shafts, including but not limited to shafts for mechanical ductwork. The idea is that the test samples that are used in the qualifying tests are the equal of the conditions of acceptance listed in ASTM E119 or CAN ULCS 101 or UL 263. These are all the same. Your furnace that you're using for your qualifying test has to be equipped with shielded thermocouples. This is not the case for ISO, by the way. That could make a big difference because our test standards in the United States and in Canada demand the use of this. It also means that during the first 20 minutes or so, there's a harsher testing, a harsher thermal shock that is experienced when you're running your furnace by means of shielded thermocouples. So ISO 6944 does not require this. CAN ULCS 101, UL 263, ASTM E119, they do require this. Further, you're running a minimum 100 square foot or 9.3 square meter sample. That's the minimum size. The fire can't get through during the test. If it does, you fail. Heat can't get through. What they're referring to is heat rise. You put a minimum of 9 thermocouples in the protected area or on the unexposed side, and if, let's say, you're starting your test at 20 Celsius, which is 68 Fahrenheit, you must not exceed a heat rise of 140 Celsius on the unexposed side. So 20 starting plus 140 is 160. The point in time at which you exceed the 160 total ambient starting temperature plus maximum heat rise, the point in time at which that occurs, your test is over with. This is obvious. You don't want to start a fire on the unexposed side. Even if the fire itself from the fire side hasn't gotten through, you don't want to start a new one on the other side. Also, the hose stream test, very critical. There must not be, once you've done your furnace test, you pull your test sample off and you hit it with a water cannon, 30 pounds per square inch, up to 3 hours. And once you get over that, 4 hours and more, 45 psi, which is 3.1 bars of pressure measured at the base of the nozzle. And this water cannon test, it traverses the test sample, and there must not be any through projection of water from the fire side to the unexposed side or into the protected area. Why do we do this? It's very simple, because it adds a measure of reality to laboratory testing that otherwise would not be there. And this is also what separates the men from the boys. Oftentimes in the fire labs, it's not unusual for foreign test samples to fail this, because they're just not equipped for that. So it's a critical safety measure, the hose stream test, and it's integral to the qualifications for shafts in North America.
Here's a common clause deflecting liability in test standards. This standard does not purport to address all of the safety concerns, if any, associated with its use. It is the responsibility of the user of this standard to establish appropriate safety, health, and environmental practices and determine the applicability of regulatory limitations prior to use. Of course, somebody has to buy the standard and see that in order to determine what this is all about. There's some truth to this. You can't simulate everything in fire testing, supposedly, but the idea that the test standard should go for the worst case scenario is sort of implied.
Okay, it's just a bit of a primer to show you wall fire testing per E119 or one of its cousins, same as S101 or NFPA 251 or UL 263. All the same thing. This is a standard North American test. This is just from a YouTube video. You can see. So this particular vendor, he's got some pins here. He's got some insulation, and then he using the pins to separate things and hold up the mesh, and then he pours on his concrete, and pretty soon he smooths it up. Then once cured, he'll lift it up, and then he'll put it into test frame. Now pay attention here. Notice that when you see these black tubes sticking into, in this case, a wall furnace, if it were a floor furnace, this would be the other direction, obviously, but whenever you see these black tubes, right, these are the furnace thermocouples that are located inside of typically Inconel tubes, which that's what actually makes for a tougher fire test in North America than elsewhere, because using fast response thermocouples results in a less severe thermal shock at the beginning of the test, when it matters a lot. So so now he's put his test sample in place, and notice too that this is normal. You're not actually having the flames touch the test sample in a wall or a floor. In a duct it might. But at the end of the 4 hours of this, obviously it ran well. There's no fire that came through, and the heat didn't come through. And then he takes it off, does the hose stream test. There we go. See, this hose stream test is mandatory, and there's no rating without it. So shaft walls have to undergo this. in order to be in compliance with the code. This is not the case for ISO 6944 or ASTM E2816 fire testing for duct fireproofing, which is sold on the basis of being an alternative to shafts. But look at the beating that this test sample is getting. And of course, this fellow's happy he's passed, right? This is quite different from the duct fire testing. So it's hardly equivalent. When we look at information on YouTube, on the net, about duct fireproofing testing, this one here comes to mind. Understanding ISO 6944, ASTM E2816. No passage of flame. Integrity, right? So what they're really referring to is an engulfment sample collapsing and permitting fire to go through outside of the furnace to the unexposed side. What this does not talk about is fire that may make it into the ductwork, or heat that may make it into the ductwork, which would then wreck the fan. And if it wrecks the fan in a pressurization ductwork system, which is there for smoke control to pressurize egress routes in areas of refuge, if the heat or fire make it in here and the fan becomes inoperable, which may happen inside of minutes, we don't really know for sure what the timeline is, right? Because neither ISO 6944 nor ASTM E2816 mandate the use of thermocouples inside of the ductwork. So the fan, which always sits inside of this ductwork, can be toast inside of minutes, and and since it's not a pass-fail criteria, it doesn't make a difference. You can get your rating this way, right? The next thing they talk about, yes, the temperature rise limit. Notice that they did actually correctly place the thermocouples here, you see. It's on, like this is the fire chamber, the furnace. This is the outside of the lab, so this is intended to simulate the protected area in a construction site. But they're only measuring what comes through in the way of heat on this side. What really, and that matters too, I don't mean to minimize that, but one thing they've kind of left out of this, check, don't take my word for it. Again, please assume I'm jiving you, but check some through penetration fire stop listings that have to do with fireproof ductwork. You will find that unlike this, there's more insulation used at the point of through penetration. Because this insulation, this extra duct insulation, because this forms part of the fire stop, right, then it forces these thermocouples out of the danger zone. So it's easy to get a T rating here per E814, the through penetration fire stop test standard, but that does nothing for the engulfment samples. It does nothing for the fan, which always sits inside of the ductwork. Why does it sit inside of this ductwork? Look at the purpose of it. The purpose is pressurization, bringing breathable outside air under positive pressure and pressing it into an egress route and or an area of refuge. No thermocouple is on the inside to make sure that we're protecting the fan that resides in here, and this can be exposed to fire in real life, right? They talk about collapse, right? The duct can't fall apart. Who cares? Who cares? Because this is going to happen way after that fan, which is electrical equipment, which should have the same protection as this here, unexposed side. Who cares whether this falls apart or not a half hour in, hour and a half in? If within minutes the fan is toast, then all of this is pointless, all of it without exception. And here, the whole stream, I mentioned this earlier, watching an E119 fire test, and yes, the fire stop portion of this is subjected to a hose stream. But the big engulfment sample, right, that sits in the furnace, which is theoretically should protect the fan, because otherwise this whole thing is useless, that's not getting hose streamed. The through penetration fire stop is getting hose streamed, right? So what this does is it may for some folks, create a false impression that there is thermal protection on account of a T rating, which should apply to the whole duct. It doesn't. It just applies to this, wherever this duct pops through a fire resistance rated wall or floor assembly. That's where that applies. If the fan is toast, this whole thing is about as useful as yoga for hamsters. Okay, this is just to show you a layout of theoretical building envelope, the building envelope on the outside, obviously, and this represents a pressurization duct system. Obviously, a couple of changes in direction. Bear in mind, those could also be vertical, not in this particular example, but in reality, this can and will happen. It's one of the reasons why E2816 was rejected in one code change proposal after another at the ICC, because it did not have a fire test for the engulfment sample of a level change from going from horizontal to vertical. So you have an air inlet at the building envelope, and you've got a fan shortly thereafter. And the idea here is that this fan draws in the outside breathable, cool, fresh air, and then forces it down this fireproof ductwork into a protected area with a discharge point. And this could be either an escape route, it could be a stairwell, it could be a corridor, or it could be an area of refuge. And the idea is that if this fresh air comes in under positive pressure, then smoke would be displaced down here. So it follows that no matter how well the fireproofing of this ductwork does, the point is that if that fan is toast, this whole thing becomes pointless, and the fan always sits inside of that ductwork. This was a presentation that I downloaded in April of 2021, but I think it's from 2011, so this could be woefully out of date, but the general principles still apply, and it contains some good information for comparison purposes. Let's go back a bit. Notice the nomenclature, air duct wrap. It's not incorrect, fire rated, duct wrap. Rated to what? To E2816, I suppose. Or ISO 69844, maybe both. Key duct wrap benefits. Air duct. Duct wrap. What needs to be discussed for real-life applications is it pressurization ductwork or smoke exhaust? And the only requirement under the building codes is for fireproofing pressurization ductwork, because that's dedicated. It's only for pressurizing egress routes and areas of refuge, whereas return air ductwork can be co-opted for smoke exhaust, but there's no requirement for that to be fireproofed. It's a dual purpose thing. Okay, concept applications, right. Take what we did with grease duct and applied to air duct, right? This being addressed to fire stop contractors, I suppose, to give them reasons to install these goods as part of their work. Shaft alternative, it says. So that's correct, because you need the alternatives process under the building code in order to get this through, because it doesn't. The building code continues to refuse the code change proposals that have come through. The latest one was in April of 2021. See, now here we're actually mentioning pressurization, smoke evacuation, smoke exhaust, right? Those are the two types that are being tested to ISO 6944 and ASTM 2816. But again, this here, I suppose the vendors would hope that people would go ahead and fireproof return air ductwork, but so far there's no requirement for that. The only thing there's actually a requirement for in the code, because this is a dedicated system for this purpose, is the pressurization ductwork. Codes and standards. Code requirements exist for ventilation ducts to be enclosed in rated shaft or fire barrier. Yes, pressurization. No allowance for wrap as an exception. That's right, because it never made it into the code for the reasons mentioned here. Smoke-proof enclosure, International Mechanical Code, testing and listings. Okay, now, this is a test sample to ISO 6944, and this is public domain information. It's on the internet for everyone to see. Notice that there's no level change here, right? You don't see a connection between horizontal and vertical ductwork. This happens all the time in the field, but ISO 6944 and E2816 don't require this. There's no drawing for it. There's no provision for it. Down below, you're seeing basically a fire stop test, right? And this is where the thermal measurement is taken. Notice too the fattening of the ductwork is kind of concealed if there's any on the unexposed side. But when you're only sticking per E814, the fire stop test procedure, when you're only sticking a foot of the penetrant into the furnace, right, and then you wrap it nice and thick, then you can get yourself a T rating, right? And looks like in this case here, the wrap maybe goes all the way around, even the bottom. Not quite certain from that picture. Yeah, this is the old way to do it, right? ISO 6944 in 1985, way out of date. It talks about stability, integrity, and insulation. And this is actually identical to British standard BS 476. In 87, these two were combined, stability and integrity. Yes, it's still there. It hasn't completely fallen apart. And integrity, nothing has gone through. And insulation, you haven't exceeded the thermal requirement. The trick here is that the insulation rating, as ISO 6944 would think of it, or BS 476, right, which is the British equivalent to ASTM E119. Believe me, it's nowhere near equivalent. The insulation that they're talking about, they're only measuring on the outside of the furnace at the point of through penetration, where they can fatten up the insulation so as to force the thermocouples out of the danger zone. So that's where you're getting your insulation from here. And this is what I'm suggesting that code officials, fire prevention officers, consider in terms of permitting this as an alternate, right? Because where's the insulation coming from? One might get the impression that the insulation means the whole duct, and yes, it is insulated, but the length of the duct, there's no thermocouple that goes on the inside of the duct during this test. It only goes on the fire stop on the outside of the furnace. Yeah, compliance. See, right away they're talking about alternates, right? Because lots of folks have installed these systems, not just this particular vendor. Forget about this particular vendor. I'm not talking specifically about one vendor or another. I'm talking about the standards. So duct fireproofing systems qualified to ASTM E2816 or ISO 6944 have been accepted through the alternate process in construction sites all over North America. And so they can approve if it meets the intent of the code, right? But the code actually says that the baseline for acceptance is ASTM E119, which indicates that you can't exceed the temperature and you have to pass the hose stream test. And they put all of that, not on the big long duct that's going all over the place. They're just putting all of that on the through penetration fire stop, a minuscule part of that, right? Value engineering, yeah, value. Oh boy. Growing acceptance by authorities having jurisdiction. And that's why I'm suggesting that authorities having jurisdiction, building inspectors, fire prevention officers, would be well advised to actually read the test standards and check where the thermocouple locations are. Because if you're a building official or a fire prevention officer and you are assuming that the fan inside of that pressurization duct system is safe from excessive heat, the way that a 2R wall would make it safe, on the unexposed side. If you're thinking that the fan is safe, think again, because there's no thermocouple on the inside of the duct in the test sample, in the engulfment test sample, that would guarantee that. Right? Existing listings are adequate. Yes, I've made a lot of money, I'm sure. Lovely, absolutely lovely. Come with a follow-up service procedure. So the test lab does well, the manufacturer does well, everything's tickety-boo. It's adequate. I can't really argue that. My point is, make sure that you're getting what you think you are. ISO, limitations. ISO 6944 uses non-mandatory language. That's because it's not the law anywhere. It's kind of like a model code, except it's a model standard. I don't know of a country that actually makes this part of the code. It's certainly not made it into the into North American codes. Code compliance difficult to articulate. It's not difficult. It's very easy. The conditions of acceptance are crystal clear in ASTM E119 for non-bearing walls. And that's what this is about. You can't let the heat through, you can't let the fire through, and you can't let the hose stream through. And these test procedures are not the equal of that. That's what they need. Individual through the alternates process. Are you getting, as a code official, are you getting what you think you're getting? That's the question. I'm suggesting that you presume I'm driving you and simply order those test standards and check that out for yourself. See where the thermocouples are and what the limiting criteria are in order to get a rating, right? Yes. See, even back then, they've been working on E2816 for a long time, but it's never really been accepted. Right? Oh yes, bypass. This is the alternates process, right? Get yourself a standard, and then the evaluation service, maybe they'll accept it. So if you work for ICCES or anyone who competes against that, think about it. Think about that fan. Think about the heat. Think about superheated gases inside of this ductwork, and the fan being toast inside of minutes, and then what is all this about, right? They have a bit of a roadblock. They've never made it into the code because they've been swatted down each time on merit. So here they're talking about, the new test standard, and this has gone through a number of iterations. They call it the North American equivalent, but then they're dissing right away. They're dissing ISO. Right? If you order this, and I suggest that you do, again, presume I'm driving you, order yourself a copy of E2816, and here's the comparison, right? Combustibility. I have to do it on combustibility test we did at the time. I think they've removed that. Flame spread. Hose stream test. Yes! It's not in 6944. That's why the test labs have done a separate sample. And E2816 has done the very same thing. Very same thing. In fact, for a while, there was a proposal going around. Listen, give me your test report for this, right? And I'll give you an evaluation that you don't have to do anything else, and you pass that. Except maybe test through penetration fire stop. And that was sort of an approach, right? Compliant mandatory language, yada, yada, yada. And of course, ISO does not mandate the use of shielded thermocouples to run the furnace with. If the testing was done in North America, then they went outside of 6944 by seeing to it that they ran the furnace the way that we do in North America, with shielded thermocouples. But if you had an overseas test, then you'd be well advised to check that, right? So here's a vertical test sample, right? And then, then there's A, B, C, D, right? Because they subdivide between pressurization and smoke exhaust. Right? And again, smoke exhaust, we use return air ductwork for that, and there's no requirement in the code. And why would there be? You think about it. You've got a room's on fire. There's a duct in there, and it's going to suck on the hot air in that room. So you've got fire inside the duct and outside the duct. What is that supposed to do? So you could say, okay, well, smoke exhaust would then be for cold smoke, or at least smoke cold enough that it's not going to on its own collapse the duct, right? 'Cause it's just like 22 gauge sheet metal. It doesn't do very well in a fire unless it's been heavily fireproofed. So if you've got fire on the inside of that ductwork, what's keeping that from collapsing? And compare some listings, certification listings with through penetration fire stops for smoke exhaust ductwork and how they can do that. One of them actually puts it's smart, put a damper inside the through penetration, because now you've got some stiffness. There are issues with dampers as well. I've made that clear in another video. So then this document, evidence of compliance, interim solution until code changes come. But those code changes never came. Here they were talking about that. Yeah, so this was from 2011. Here they're talking about, oh, the proposal is due for 2012. Next code cycle is 2015. It got rejected. Everything got rejected. Nothing made it into the code. All of this was for naught. The listings are still valid. Just because it's listed, that doesn't mean that it meets the intent of the code. If the intent of the code is shaft walls, which require compliance with ASTM E119, meaning that you are the equal of the conditions of acceptance for non-load bearing walls. Fire can't get through, the heat can't get through, the hose stream can't get through, and you don't get to separate out the fire stop and just beat up on the fire stop in terms of through the hose stream and the thermal requirements, and then the rest of it is okay with minimal protection. Multi-year transition. Multi-year transition. Yeah. In 2021, August, the ICC hearings in front of the committee, it was swatted down. Key duct wrap benefits. Oh, it saves space. Of course it saves space. What's the thickness of a 2-hour fire resistance rated wall that is qualified by means of testing to ASTM E119 or its cousin standards S101, NFPA 251, or UL 263? You're looking 4 or 5 inches at least, maybe more, right? 2 layers of drywall on each side, rock wool in the middle, studs. It takes some room. So obviously, if you have a single layer of ceramic fiber in a baggie, or other system, there are other systems, not just these flex wraps. There are other systems as well. Look at the thickness. And then try and imagine, how do I keep, if I've got like 1100 degrees on the outside of this, how do I keep the inside of the duct from heating up beyond a heat rise of 140 Celsius? If I've got 1100 on the outside with a single layer, this thick, 1.5 inches thick of this, or there's a composite panel that's like 3/8 of an inch thick, and then there's a sprayed on product as well. I'm not saying any of these are bad. It's all wonderful stuff, right? Sold by wonderful people, installed by wonderful people. My point is, if there's no thermocouple that's mandatory in E2816 or ISO 6944, how do you keep the fan from shorting out? Because you actually need an electrical level of fireproofing, so you can't exceed the maximum heat rise of E119 on the inside if you want to safeguard the fan for the pressurization duct. Job site obstruction. Yeah, of course, everything is lovely. You can just run it through, and it just makes it a little wee bit thicker maybe, and away you go, right? Do it in condos and high-rises, right? HVAC. Yeah, never mind HVAC. There's pressurization, there's smoke exhaust. Smoke exhaust, you can safely forget about. Nobody's paying for that to be fireproof these days. Not in North America. For what? Right? How are you going to test it? They actually test it, and then you've got fire inside the duct and outside the duct. What good is that supposed to do? It's going to collapse at the point of through penetration unless you fix it. You hold it in place somehow. And what good is any of that doing? Right? That's what has to be made very, very clear in order for a code change proposal to succeed. Yeah, high-rise residential condo. Access for damper, maintenance, inspection not possible when damper. No. Yeah, dampers. There's discussion about dampers. If this duct fireproofing were the equal of the conditions of acceptance for walls, non-load bearing walls in E119, if they were the equal of that, then you certainly wouldn't need a damper at the point of through penetration. It would be detrimental. Either way, it's detrimental. Even for smoke exhaust, if the damper shuts, you're not exhausting any smoke, right? That's sort of counterproductive, isn't it? If it's pressurization ductwork, you're sending cold air through to the protected area. Why would you want to damper that? Well, maybe because your duct fireproofing is not really the equal of the conditions of acceptance of E119, which is what the code intent is. Yeah. It's all about dollars, isn't it? Materials, resources, yeah, recycled content, yada, yada, yada. Yeah. Energy savings. Okay, energy savings. Look, for pressurization ductwork, it's irrelevant, right? It's only there to pressurize for smoke control. For return air, you could see wanting to insulate that. But again, there's no requirement for fireproofing it. So if you wanted to insulate that to save on energy during normal operation, not in a fire, there's nothing wrong with that. You don't need to go to the point of fireproofing it. You use any normal duct insulation for that. Yeah. Sound transmission and absorption. Sound properties. What do you think holds back sound better? A 2-hour rated wall or an 1.5 inch of ceramic fiber in a baggie? Now look at this. Okay. Key benefits. The summary. AHJ and building inspector. Code compliant. Yes, it's code compliant if these guys accept it as an alternate. And the point of this is to suggest to take a closer look at the standards to make sure that what you're getting in this alternative process is actually the equal of the code intent. Summary. See, now, and why would anybody do all this and jeopardize the fans and so forth, right? I don't know, could this be, this have something to do with it, perhaps? I mean, it's not a bad thing, right? Like, if you're a vendor of a construction product, you want your contractors to make a good living. That's all good. There's nothing wrong with that. What may be objectionable to a building official is the realization that the host stream resistance and the thermal performance of the systems qualified to ISO 6944 and ASTM E2816, that's not as intended. That's not that actually comes from the fire stop portion of the test, which is minuscule, right? We're talking about big, long stretches of ductwork up and down and sideways in a building, right? So it's okay for everybody to make good money, but if smoke exhaust is irrelevant because return air ductwork does not have a requirement in the code to be fireproofed, so if that's out of the way until somebody finds a reason to convince code officials to go for the extra expenditure of fireproofing return air ductwork, until that happens, the only thing really at issue is pressurization. If the fan is toast, the pressurization ductwork is purpose-free. Right? Questions? Yeah, how do you keep the fan that always sits inside of the ductwork? How do you keep that operational? So let's take a quick look at the oldest trick in the book, no rhyme intended, in the fire stop industry, how to get a T rating without any brains. All you have to do is insulate the penetrant. Now in this video, I've indicated that the way that one might get a false impression from ISO 6944 and ASTM E2816 test results and listings, advertising possibly, and so forth, is that there is a mention of thermal performance. And the thermal performance comes in the way of testing basically by beating up on the fire stop. Right? So think about that. Think of how many lineal feet of a duct system you may have in a building, and how many lineal feet of that are going through fire resistance rated walls and floors at the point of through penetration. That's a minuscule portion of it. And the host stream performance and the thermal performance data that comes from those tests, where they tell you about insulation ratings and so forth when it comes to ISO 6944, you know, the included testing, separate test sample for E2816, all of that information is derived from the fire stop. So what is being used here is what we know in the fire stop industry as the oldest trick in the book. So I'm going to show you now a fire test here that has a bus duct in it. And I can already hear the complaints. Well, bus duct, that's electrical. It has nothing to do with mechanical. Yeah, just look at it, use your common sense, and I'll show you how this relates. So the two bus ducts used in this fire test, one with aluminium bus bars, which are basically flat bars for conducting electricity, sheet metal, top and bottom, and then stiffer side rails. This is used for conducting large amounts of power in buildings. Just to ward off against idiotic arguments against this line here, which is bus ducts have nothing to do with mechanical ductwork. It's irrelevant. I would have to be a complete idiot to bring such a thing up. There's a reason why I'm doing this, okay? Bus ducts are more critical. Why? In a fire situation, you've got conductors going right through on the inside of the bus duct, and you've got combustible material. There are wrappings that surround each bus bar, and those are sold on the basis of, oh, the plastic, there's mylar on there, it's rated to 130 Celsius. Sounds really exotic, especially for people using the imperial measures like Fahrenheit. 130 Celsius is nothing, okay? Building fires get upwards of 1100, right? Again, I'm encouraging you to believe that I'm jiving you, and buy the test standards, check it out for yourself, see what you think, okay? Look at the time temperature curve. Rated to 130 Celsius for the mylar wrappings for a bus bar is nothing compared against a building fire. So the reason why I'm making this comparison here is because this is a more severe case, right? To try and get a T rating on a penetrant, on a through penetrating item, going through a fire resistance rated wall or floor assembly, right? You will have a fire on the inside, and I'm going to prove that now. By the way, all these pictures from the bus duct testing, this is all on Wikimedia Commons, right? They're all in there. So let's go to this one here. Okay, it's just a detail, like a top view or cut through a bus duct. Okay, let me absorb that for a sec. So cracking open this particular bus duct, one can see the bus bars, and each bus bar in this case is lined with mylar. Here's a close-up of the wrappings. These wrappings, 2 layers, rated for 130 Celsius, plus the plastic spacer tubing, provide for fuel and smoke. It can impinge on the other side. Just to compare, when we're comparing bus duct against pressurization ductwork, obviously there's nothing on the inside because it's meant to convey air. This particular one is a factory-built version with a composite panel, whereas the flex wrap ones are ordinary sheet metal ductwork with an exterior layer of flex wrap, or in some cases a spray-on product. But obviously these are empty on the inside. So the point I'm making here is that if you can get a T rating on a duct that's crammed full of conductors and combustible materials with a live fire on the inside, if you can get a T rating on that, obviously you can get a T rating on this if you're only measuring how much heat comes through to the outside of the fire stop on the unexposed side, which then can lend the impression that the thermal performance of the fire stop portion of this, which is a minuscule content of the ductwork in a building, if you can get a T rating on that, or if you can get a T rating on something that burns on the inside, then obviously you can get it on this as well. Get a load of this. These plastic tube spacers go between bus bar sandwiches inside of a bus duct. So on the inside, so all that stands in the way of fire and smoke going through from one side to the next. Obviously, this burns well, and you will see the evidence of that in a moment. Right here, the 2 bus ducts hung in place in a test rig with a mock-up floor system, and this is about to be fire stopped. Right? So, and this is normal for fire stop testing. 3 feet extend on the unexposed side, 1 foot goes into the furnace, plus add the thickness of the floor system in this case. Right, at this point it's been fire stopped with a through penetration fire stop material, a mortar in this case. You're looking at the underside actually. The whole thing is cured at this point. And notice how the bottom of this is capped, right? Usually pipes you can cap more easily, just fasten a cap on. In this case here, it's a sheet metal cap and it's stuffed with ceramic fiber, because the bus duct itself has issues, right? Like this is held with plastic and so forth on the inside, so this whole thing on the inside could possibly come crashing through and down, which almost happened here. But here's the fire stop mortar, and here are the 2 bus duct. One is aluminium and one is copper. And here's the trick actually, the oldest trick in the book. I put insulation right there, 2 feet tall. Right? This sticks out 3 feet total. This insulation sticks up 2 feet. Why 2 feet? That was an agreement with the test laboratory. Why? Because I had to defeat the thermal issue. Why? Because this is going to get awfully hot on the inside, right? At first, I wasn't going to do this. The hell with the insulation, I was going to fire stop the inside. Test lab said no. Why not? Because when the bus ducts themselves are tested for electrical safety purposes, which excludes fire resistance, then there was no fire stop on the inside of the bus duct. That would change, in particular, the ampacity derating of the bus duct system itself. So if I fire stop the inside of the bus duct, then the bus duct itself would be outside of its own certification listing. But by placing this on the outside, I'm also violating the bus duct listing itself. Why? Because all of this insulation and also the fire stop, right? The fire stop plus the insulation, all alter the ampacity derating function of this bus duct system. So by making the fire stop part of the fire stop system, right, we put in fire stopping, we put thermocouples 1 inch up on the penetrant itself, and on the fire stop 1 inch away from the penetrant. So by putting this insulation here, I'm forcing the thermocouple from 1 inch up down here to 1 inch up over here. And instead of 1 inch over from the bus duct itself, which is burning on the inside, I'm moving it 1 inch away from here. So it's a way of circumventing the system, and this, in essence, is the oldest trick in the book. And this exactly is what folks are using to get into the alternative path of approvals for pressurization ductwork according to the International Building Code. Because what they're doing is they're using this particular old fire stop trick, right, to deliver thermal data that can be misconstrued by some folks to think that, oh, the inside of the duct is safe, therefore the fan is safe, right? Obviously, this is a bus duct, doesn't have a fan on the inside, right? But I'm making that comparison. If I can pass with a T rating with this, with conductors and with combustible material on the inside by using this old fire stop trick, by insulating, right? If I can do that here, then certainly with an empty air duct, I can do that as well. And that's the whole deal. Here's a shot from the inside of the furnace. And you clearly see the fire stop mortar and the couple of bus ducts that are in there. Of course, there are other penetrating items as well. There's piping and cable tray and so forth. Minutes into the test on the unexposed side, or what in a building you would call the protected area, you can see that smoke emanates from the inside of this. Why? Because the wrappings and the little tube spacer bars inside of the bus duct are being converted into smoke. And it's pretty bad, like right to wear basically scuba gear near there, you know, for added comfort. You can see a plume of smoke going up from it. So none of this would happen with a pressurization duct, right? Why? Because there's nothing on the inside that is burning and smoking. This is a more severe fire stop test. Why am I making the comparison? I'm making the comparison because the more severe thing passes. And that same old lesson, this is nothing new, insulate your penetrant to force the thermocouples out of the danger zone. This is what's being used to obtain T ratings, and then to indicate that thermal performance, which may be misconstrued by some folks as thermal performance for the fireproofing of pressurization ductwork. You see it all come out. And it passed. After the fire test, then the assembly is pulled out and it's subjected to a hose stream test. Notice as well down here, these are the copper bus bars, and here's the aluminium. These pretty well melted and turned into a puddle at the bottom of the furnace. These guys nearly crashed through here. Notice how the cap is kind of taken a beating there, right? And then it gets hosed. And because the TCs, the thermocouples, were placed outside of the danger zone, that's how you get a nice thermal rating. Now, Doing a post-mortem, having torn this out of the test sample, here's what we see on the inside. So these 130 degrees Celsius rated Mylar wrappings have cooked off pretty much. And all of that smoke went into the lab on the unexposed side. And as it turned into smoke, it went through fire first. And that's why the insulation was necessary on the unexposed side. Obviously, these are the aluminium bars. This was the fire side. You can see the cap here, and there's like nothing there anymore. Only the side rails, which were steel, but the aluminium bars themselves are gone. A little bit left, right? Because in this case here, the of the wrappings, I'm saying, because if the aluminium disappears in the fire, then there's less of it to conduct heat all the way up. But there wasn't much left. So here's basically proof positive that with a live fire on the inside, provided that you put insulation at the point of through penetration and you fatten it up enough, you can get a T rating even if you have a live fire on the inside of a duct system. So if anybody tells you that this comparison is inapplicable because it's electrical, right, they either don't know what they're talking about or they have some other motivation, because this is more critical. And with a more critical system, you can get a T rating. Look at the T rating which tells you the thermal information that's being offered for testing of pressurization ductwork in ASTM E2816 and ISO 6944. They're getting you both the hose stream and the thermal data by beating up on the fire stop instead of the engulfment sample. Contrary to what you might hear, the electrical comparison, electrical fireproofing, is an apt comparison here for a number of different reasons. You have to protect what's on the inside for circuit integrity, but you also have to protect what's on the inside for pressurization ductwork, right? The fan on the inside, if you locate it on the outside, not so bad, but if it's on the inside in a fire compartment, it should be fireproofed. A, and B, the air. Do you want superheated gases? Do you want superheat from a fire to go into the protected area? Probably not, right? For electrical, that's tested for because they put the thermocouples on the inside. So this is Wikimedia Commons, public domain information. Just click on one of these. Finally, okay, well, here's a test sample being put together. So for electrical fireproofing, which is an apt comparison, we basically build a big C and turn it sideways, right? So you have a fire-resistive floor assembly here, and then you're popping through the slab, and around and back up the other side. Right. Actually, that went a bit far. Maybe not. Okay, so fireproofing was placed around. Notice there's
there are two level changes. You have the, in this case, it's a cable tray. And it's got fireproofing placed on the outside. And it extends 3 feet on the unexposed side. Why? Because that's the fire stop portion of the test. We always have the penetrant sticking out 3 feet on the unexposed side. And but then it goes down further and horizontal, and then does 1, 2, 3, 4 changes in direction. This is one of the things, actually, in one of the times where a code change proposal with International Building Code failed, that was attempting to get ASTM E2816 into the code, so you don't have to go the alternate route any longer, right? It was a building official, Tim Pate from Broomfield, who objected to E2816 because it didn't have this level change that we have for electrical fireproofing. Yeah. Do the hose stream after, and that's your test. Of course, my computer would take a while now as I'm doing a video. But when we look at it, yeah, here it was being set up. It is in the furnace. Fire's on. Bit of steaming. Right? After the fire test, same as through penetration fire stop test, same as a wall test, a ceiling test, a floor test. Afterwards, gets lifted up and out. For a floor by itself, per E119 or S101 or UL263, you don't have to do a hose, but for walls you do. This is one of the criticisms that rightfully the duct fireproofing folks point out. When you test a wall system or floor system in accordance with E119, you don't have a 3D system, you just have a flat surface. They have a 3D system, both for electrical fireproofing and for ductwork. However, in electrical fireproofing, there's the inside is instrumented. There's actually an 8-gauge copper wire that runs along the inside of the cable tray, and it's got thermocouples every 6 inches. So if the limiting temperature were to be exceeded on the inside, whatever point in time that happens in, that's your rating. Your test is over with. And it should be the same way for pressurization ductwork, because if the fan is toast, the fan sits on the inside, oftentimes sits on the inside of the ductwork in a building, inside of a fire compartment, which could be engaged in fire, right? You want to be able to safeguard that. And in fact, this was tested without any wires in it. Why? Because wires actually make it safer to pass. Why? Because you've got an additional heat sink. Even if you energize those cables, that's just a whole lot of mass that can absorb heat away. So in this case here, this was tested empty. We're just seeing what heat comes through. Right? And then it gets hit with a hose stream test, which you saw in the earlier pictures. So, this is all in the public domain. So, if it's possible for electrical fireproofing to do a level change, then why can't that happen for duct systems, right? There's no reason why it can't, and it would be up to the task group in at ASTM to suggest such a thing, right? Instead, again, presume I'm jiving you, but take a look at the test standards. They do a horizontal sample, they do a vertical sample, which they take out of ISO 6944, 1985 version, which they've all tested to, and but never the two shall meet, right? In the vertical test sample, they have the little nubbin of a T connection to nowhere that sticks out. If you test it like this, which is what we do for electrical, then the inside, if it passes this test, the electrical fireproofing test, right?
there's one out of UL. There's an ASTM one without a hose stream test. And there's generic letter 8610 supplement one out of the US NRC. So these are the test standards that we use in North America to evaluate electrical fireproofing. So if it passes this, right, then it's good. A fan would be adequately protected. This would actually meet the intent of the code. The intent of the code for pressurization ductwork, it mentions ASTM E119. So if it passes the conditions of acceptance, fire can't get through, heat can't get through, hose stream can't get through. For the whole thing, not just the fire stop. See, for the ducting, the only instrument on the unexposed side, and they hose the fire stop portion of it. Well, what about this, right? In the electrical fireproofing, you can't blow through to the inside, right? And that's the level of protection that is given in ASTM E119, which is code intent. Fire can't get through, the heat can't get through, the hose stream can't get through, and you don't cherry pick and just separate out the fire stop. The whole thing is meant, right? So there's no reason why this could not be done for the ductwork. If this were done for the ductwork, I don't see any obstacle to having this go into the International Building Code. So for a moment, let's bring this back to construction reality. You've got a building. I'm just showing an imaginary or hypothetical floor here, air inlet, and then you've got the pressurization fan, and then you're pressing that down, that air down and into the protected area so people can breathe. So this fan, when it's located on the inside, needs an electrical level of fireproofing. Same as code intent for shaft walls, which is ASTM E119, right? Having said that, here's an example of a fan enclosure, a drawing, where the fan is actually inside of an enclosure that's been rated to ISO 6944, right? So being that neither ISO 6944 nor 2816 put thermocouples on the inside, we actually don't have data, except that we don't have data in terms of how much heat arrives on the inside of that ductwork. We only know what goes through the fire stop portion and onto the unexposed side, where they're using the oldest trick in the book in order to get a favorable rating. Now, they're not lying, right? These vendors, they're giving you results, but my point is make sure that you know what it is that you're getting by understanding, right? Understanding the test regimen, right? So if the fan is on the inside, which often happens, if the duct goes up and down and sideways, and level changes between horizontal and vertical aren't tested, if you're concerned about how hot does it get on the inside here, right? Because if it gets to be 1,000 Celsius on the inside here inside of minutes, and then that is pressed down here, whether that's on the inside or not, if that's an issue, how hot does it get in the protected area? Picture yourself on the 30th floor of a building. You're in an area of refuge, there's a fire on, you can't get out, and it's blowing totally hot air in. Not so good. Blowing cold air, way to go, excellent, that's what you want. In order to have that happen, you need an electrical level of fireproofing for the fan, and likely for the whole duct, right? Because if it gets to be too hot because you don't have enough insulation, like if you've a level of protection that may be, that thick or even that thick, whereas a 2-hour rated wall might be this thick, right? That's code intent to give you real protection, so that you on the unexposed side or in the protected area, you're not exceeding 140 Celsius. That's not what's happening here, right? With if you're accepting as an alternate systems that are rated to ASTM E2816 or ISO 6944, then you're getting this. And by the way, the vendors, when it's a a manufactured system, and they know how much heat comes through. They see these on their floors, on their shop floors, because these fans are delivered to the duct vendors and they mount them on the inside, and then the protection is on the outside. But again, bear in mind, how much thermal protection are you actually getting, right? What are you playing with? You're playing with what actually might arrive here. If the fan is toast, nothing arrives. If the fan is not toast, but you're heating this up so much that you're then sending hot air in here, then what are you really gaining? And that's the whole point. The whole point in this. Okay, at this point, let's look at categories of UL listings that have to do with fireproof ductwork. There's an umbrella category. Within each category, you've got listed systems, right? Certification listings. The preamble has some bearing on what's inside. So there's an umbrella category that's HNKN. And again, presume I'm jiving you. Go to search for UL product IQ, and you can get yourself a membership there. It's public domain. You don't have to pay for anything, and you can poke around in there and check it out for yourself. Presume this is all BS, but and judge for yourself. So under general, there's some generic information you can't interchange. But below, you'll see there are three categories of fireproof ductwork. The first one is for grease ducts. These are actually typically very well insulated. Like these are, I don't have any qualms about those, because they can take a fire, whether the fire's on the inside or the outside, and they're really tough. So I don't struggle with those in the slightest. If they use grease ducts for pressurization ductwork, that would actually be a solution to all this, because it's at least double the thickness, and that makes a huge difference. So, so if we look at the first one, there's for a description of ventilation duct assemblies investigated for fire resistance, see ventilation duct assemblies. That's what we've been talking about in this video all along. There's also another one, which is HNLN, the one at the very bottom. For a description of uninsulated ventilation duct assemblies investigated for fire protection, see uninsulated ventilation duct assemblies. And from what I gather, there's a product in there that's sprayed on. And we'll look at these subcategories in just a sec here. So here's the UL preamble to the guide HNLN. First paragraph. This category covers the fire protective performance of uninsulated ventilation duct assemblies investigated to ISO 6944. Now, what is this? Bare sheet metal duct? No, apparently there is a coating involved, and so this is kind of a hybrid system that if you wanted to add insulation onto it for better, greater listings or whatnot, then you're free to do that in the field, but the duct comes fabricated with the coating on it. That's my understanding of it. Again, don't take my word for it. Presume it's all BS that I'm telling you. Check it out for yourself. Check out, go to ul.com, go into or UL Product IQ, get yourself a membership, and you can search this for yourself. Now, this test measures the ability of a representative ventilation duct assembly to resist the spread of fire from one compartment to another without the aid of fire dampers. Okay, we've got two kinds of ductwork that people want to or think about fireproofing. There's pressurization and there's smoke extract. There's no requirement in the IBC, in the International Building Code, for fireproofing return air ductwork, which is usually co-opted for smoke exhaust. So at least pressurization ductwork. So what they're talking about here is not protecting the inside of the duct, where the fan sits, where the air goes that is supposed to be pressed towards
an area of refuge or an egress route so that people can escape and can breathe and survive the fire, the building fire, right? They're not talking about the inside. They're talking about, oh, the duct pops through a rated wall or floor, and then the fire wouldn't pop through that duct to the other side, to the protected area. That's a totally separate deal. Okay, if the duct isn't insulated and that coating, well, let's read about what UL has to say about the coating. They may look at that as, not a nice way to put it, but just take it for what it's worth. The second paragraph here. The individual certifications identify a minimum clearance of 18 inches to combustible items. Think about that, right? Whether something's combustible or not, do a test of the material to E136, and then you'll know whether it's combustible or not, okay? So a duct system, a fireproof duct system listed under UL Guide H and LN, can get so hot that a minimum distance of 18 inches must be guaranteed for the life of the building. So each tenant has to know, don't park your furniture too close to this particular duct, because that could be problematic. There's a reason why they designate this minimum 18-inch distance to combustible items. Third paragraph. Oh, well, and what of the fan? Is this going to be used for pressurization duct work? If the duct gets so hot that if anything were closer than 18 inches to it, in a protected area, it may catch fire, start smoldering, right? What do you think has already happened to the fan? The fan it's electrical equipment. It needs to be protected against heat. The 140 on average, 180 single point hotspot temperature rise on the inside of the duct. However, neither ISO 6944 nor ASTM E2816 mandate the use of thermocouples on the inside. So what does this actually do for you? You think about it. If the fan is toast, what does this do for you? And they're telling you. Nobody's lying to you here, technically, if you actually read it, right? Third paragraph, ISO 6944 defines performance requirements for ventilation duct assemblies in terms of insulation, integrity, and stability, which was in BS 476. That was combined, I think, in 87. Stability and integrity was combined into one, so I assume when they're talking about the ISO 6944, they're probably talking about the 1985 version. They're no longer identifying that in here, oddly enough. So they're telling you that the insulation, again, third paragraph on the right side, top line, insulation is the measurement of the ventilation duct assembly's ability to limit the temperature rise on the surface of the ventilation duct assembly in a non-fire environment, so testing-wise, outside the furnace. So not inside the duct itself, outside, where the fire stop is, right? They like to beat up on the fire stop and then use the performance of the fire stop to ascribe to the whole duct. And this is what can be confusing. You have to actually read what it says to understand this. So the ability to limit the temperature rise on the surface of the ventilation duct assembly in a non-fire environment from reaching an average temperature rise of 140 Celsius, 252 Fahrenheit, and a maximum temperature rise of 180 Celsius, 324 degrees Fahrenheit. Integrity is the measurement of the ventilation duct assembly's ability to resist passage of flames and hot gases in a non-fire environment. Stability is the measurement of a ventilation duct assembly's ability to resist collapse, which would prevent the ventilation duct assembly from performing its intended function. See this here, think about this, right? This thing gets so hot that you have to maintain an 18-inch distance. that means that the duct is so hot that the fan is toast. So when they're telling you here at the bottom of the third paragraph, this would prevent the ventilation duct assembly from performing its intended function. Well, if the intended function is pressurization and the fan resides inside of the pressurization duct, that fan is then toast. Therefore, the intended function is null and void because you don't have any insulation in here to keep that fan cool. And never mind the fan. Just, if you disregard that for a moment, disregard the fan for a moment, if the air on the inside of the duct, as a result of a fire outside of the duct, gets so hot, superheated hot gases flowing through there to the protected area, what's the point? I mean, are we trying to fry people? What is the point of sending really hot air to egress routes and areas of refuge? Picture yourself on the 20th floor of a building above the fire department's ladder height, let's say. You're stuck. You can't get out. And then you are getting superheated air, and that's if the fan were functioning, If the fan is toast, you're not getting anything. That's why they don't get into, what is this? They're talking about air duct, they're talking HVAC and so forth, instead of being specific, like we do on a construction site. What is it that you are building? Is it pressurization or is it smoke exhaust? Last sentence here, last paragraph. Uninsulated ventilation duct assemblies do not limit the temperature rise on the surface of the ventilation duct assembly in a non-fire environment and have an insulation rating of 0 hours. Yeah, they don't get a T rating on the fire stop, in this case here, because they're not actually applying any insulation. Uninsulated ventilation duct assemblies are intended for use in environments where the clearance to combustible materials and combustible assemblies is at least 18 inches. Yes. And where you're leaving the functioning of the fan to what? A deity? Is Scotty going to beam something in? I mean, what's going to happen? If it gets so hot in there, what's the point? It gets so hot that the tenant is expected to keep a distance of combustibles to this duct popping through a wall or a floor somewhere. That's what they're telling you. Okay, here's the second and last part I'll get into for the UL preamble to the guide HNLN, which is uninsulated fireproof ductwork. This is with a sprayed-on product, apparently. There's a bunch of blah blah about ISO 6944. This is all the lovely stuff about it, which doesn't tell you pressurization, smoke exhaust, something else maybe, right? Let's bring it to reality in construction. Pressurization ductwork is at issue. There's no requirement to fireproof return air ductwork, which is used for smoke exhaust. The bottom here in yellow, they tell you that the fire stop portion of it has to be tested to UL 1479, which is ASTM E2816, or CAN ULCS 115. They're almost identical, those. The F&T ratings of the fire stop system, the first highlighted paragraph here, should be equal to or greater than the hourly insulation rating of the ventilation duct assembly. Right, so yeah, if your duct assembly has a 0 insulation rating, then it's okay for the heat to cook through on the fire stop as well, and if otherwise, then not. But notice too, authorities having jurisdiction should be consulted before installation. And if you are an authority having jurisdiction, it is a dereliction of duty if you do not have a copy of the test procedure, the test standard, and if you haven't read it. Because otherwise you're approving stuff potentially that you do not understand. It's very important. Right? Just because something is listed by a laboratory, that doesn't mean that it's okay under all circumstances. The laboratory in this case here, UL, tells you a whole lot of information about this. And you need to think about the exact purpose on the construction site. If you're going to use this, how would you get with the fire prevention officers afterwards who are responsible for the turf that this occupancy is on to say, listen, you better get in there and make sure that they don't move any items too close to this ductwork, because if it gets within 18 inches of it, then it's outside the listing and bad things may happen. Right? You need to think about those things. What's the likelihood of that afterwards, right? So, I mean, theoretically, you could put signs everywhere. You know, or don't get too close with anything, right? And what about the fan? Oops. How are you going to keep the fan safe if there's no insulation on there and the duct gets so hot that it radiates too much heat that you can't move anything near it? That may have issues because it doesn't pass ASTM E2816 testing. Very bottom, the properties of these ducts, including fire resistance, other than those specifically detailed in ISO 6944, and the degree of fire protection of specific duct assemblies have not been investigated. Notice, again, they're not telling you here, and maybe they will at some point. I just downloaded this, let's see now, 12th of May, 2021. This is what it says. There's no indication of what date is meant. ISO 6944 1985 is different from the 2008 version. Right? In 2008, by the way, they also test for the impact of metallic duct expansion, which would put a force onto the fire stop that it goes through. Right? So that's not tested to E2816, and you know, if you haven't tested that, what if the duct grows an inch, 2 inch? Is that going to tear a hole into the fire stop? Have you then tested that with a force on the penetrant with your through penetration fire stop assembly? This is where you need to know these standards. If you're an authority having jurisdiction, you need to know these standards before you approve stuff. If not, kind of a gamble, isn't it? They're telling you exactly what's going on. All you have to do is read it for yourself. Don't take my word for it. Get a copy of it. Read it. See what it means. Where are the thermocouples? What does it mean? What if the duct expands? Right? Is sheet metal ductwork immune from the expansion that structural steel undergoes? I think not. Right? So know what you're getting into. Okay, let's look at a real piece of rated ductwork, rated to ISO 6944. It's not with the coating type. This is the composite panel one, not insulated. Doesn't need to be insulated for the whole run of pressurization ductwork. And but notice what happens at the point of through penetration. Here you have a through penetration fire stop test. Again, nothing wrong with any of this. It's lovely. The same duct you just saw, the uninsulated duct. At the point of through penetration, however, it's insulated. This one here, the chooses rock wool. That's fine. Nothing wrong with that. But what this does, and you have a foot of the penetrating item reaching into the furnace, right? Not a whole engulfment sample, right? There's no pushing if there were expansion taking place or whatever. Because you're not testing for that. This is tested to ASTM E814 or UL 1479 or CAN ULC S101, S115 rather. And by putting that insulation onto the ductwork at the point of through penetration, the thermocouples are moved out of the danger zone, right? And then the thermal performance of that system can be misconstrued as applying to the whole duct. Well, this whole duct is uninsulated in this particular example. Same as in that guide HNLN. They're talking about uninsulated ductwork, right? Which is, from my understanding, normal sheet metal ductwork, but with a proprietary spray on it. So if there's no insulation of any kind of substantial thickness, then how's the heat prevented from getting in is the question that I would ask. And secondly, if the test standard doesn't call for the thermocoupling, the instrumentation inside the duct, in the engulfment sample, what's going to happen to that the fan, or the air, for that matter, that's going to the protected area, right? This is how you get a pass in accordance with ISO 6944 and ASTM E2814 and 2816 and all of that stuff, by seeing to it that the point of through penetration is insulated in such a way that it gets you a great thermal rating, a T rating. This sketch here is just arbitrarily lifted from one of many certification listings where you've got a duct qualified to ISO 6944 and or E2816, and at the point of through penetration here, in this case it's a floor, so it's a vertical piece of ductwork, and there's some extra insulation added. Why? Because that extra insulation forms part of the fire stop system, and where you measure the temperature on the penetrant 1 inch up from the fire stop, and on the fire stop 1 inch away from the penetrant. So 1 inch up, 1 inch over. By putting that insulation in there, you're moving the thermocouples out of the danger zone. And then since this is co-mingled with ISO 6944 and ASTM E2816, it gives you the only thermal information, which is then quite possibly misconstrued as being applicable to the entire duct system, which could then be misconstrued as to safeguard the fan, if the fan is located inside the ductwork, right? But really, we're beating up on the fire stop, and then whatever good the fire stop does, great for the fire stop, but what does it actually do for the ductwork? That's the point. So the other category of fireproof ductwork for under the UL product IQ is HNLJ. And the difference between this and the previous, the HNLN, is that this is insulated. So this achieves the insulation rating per ISO 6944, which again is based on the performance of the through penetration fire stop. Notice where it says non-fire, it's sort of underlined in red in the second paragraph. Insulation is the measurement of the ventilation duct assembly's ability to limit the temperature rise on the surface of the ventilation duct assembly in a non-fire environment. That means outside of the furnace in terms of fire testing. So it's in the protected area, not inside the duct itself, where you may wish to keep the air that you're pressing into your egress routes and areas of refuge, where you may feel like it's a good idea to keep that air cool and to keep the fan operational. We're not testing there. There's no thermocoupling there. So that what they're telling you here is that the thermal performance don't exceed a temperature rise of 140 Celsius, 100 on average, or 180 single point hotspots. Don't exceed that on the unexposed side of the fire stop. That's what they're telling you here. Right? The rest is, fairly academic. We've already gone over it. Non-fire environment. So here's the second part of the HNLJ preamble. So condition A, B, C, D, imported from these two test standards, highlighted at the very bottom, ISO 6944 without identifying the year, and ASTM E2816, same thing. So one is pressurization, the other one is exhaust, and one is vertical, and one is horizontal. And this shouldn't all be separate. First of all, smoke exhaust, there's no need for this until the ICC decides that we need to fireproof return air ductwork. That hasn't happened yet. No case has been made. So forget smoke exhaust. That leaves pressurization. So then we're separating horizontal versus vertical. This was one of the big reasons that it was that the code change proposal to include E2816 in the International Building Code failed a number of years back, because Tim Pate of Broomfield correctly identified, well, wait a minute, the horizontal and the vertical, they join in the field, and we should be able to test that. And we do for electrical fireproofing, but for mechanical we haven't. The idea is that, well, maybe we should. You know, this is one of the various reasons that called these code change proposals to fail. So condition A, B, C, D, you know, it's all lovely, but it's not all that relevant. We need pressurization, ductwork fireproofing, or inherently fire-resistive pressurization ductwork that safeguards the fan if we want to actually fulfill the purpose of this whole thing. Notice again in the second set of highlighting here, F and T ratings of the fire stop should be equal to or greater than the hourly, blah, 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 blah. Again, the only thermal information you get is the performance of the fire stop. So if I fatten up the insulation at that point, I can push the thermocouples out of the danger zone. I get lovely thermal data, and that's the only thermal data I get. I don't get any data in terms of what is the heat that arrives inside. If I want to know what the heat that arrives inside, if you use the test method for grease ducts, or if you use the test method for for electrical circuits, that's the best one. They put lots and lots of thermocouples on the inside to safeguard electrical circuits. That's the point. And you have a level change from horizontal to vertical. In one test sample, you've got 4 changes of direction. So, and here we're highlighting what does the fire stop do, and then this is misconstrued as at times as being the performance of the entire system, which doesn't do that much that I can see for the air. What is that air like? How hot or cold is that air that's getting into the protected area, into egress routes and areas of refuge? Whether the fan is operational or not. Right? It doesn't address those things. And at the very bottom, the basic standard used to investigate these ventilation duct assemblies, ISO 6944 and or ASTM E2816. So if you're an authority having jurisdiction, you cannot presume to do your job on this to permit an alternate under the code unless you have a copy of these standards and you've read and you've understood it. Without that, what are you basing your decisions on? And that's the whole point. I'm not trying to make anybody look good, bad, or indifferent. My point is, to the authority having jurisdiction, know what you're getting into. So the last segment on this, Google search results for potential legal exposure in the United States and Canada from creating, promoting, using a standard, ASTM E2816, and or using an obsolete standard, ISO 6944 from 1985, testing to which results in representing thermal and host stream fire stop test results as being applicable to full runs of pressurization ductwork, including duct internal electrical fans, as meeting code intent for shafts, which code intent is based on ASTM E119, UL263, or CAN ULCS 101, those are all the same, conditions of acceptance for non-load bearing walls. Meeting the conditions of acceptance of E119, UL263, and S101 means fire, heat, and hose stream would not penetrate to the inside of the duct, thus safeguarding the duct internal pressurization fan and delivering cool, breathable air under positive pressure to the protected area. Code intent cannot include the intentional delivery of superheated air to the protected area, for example, to the extent that the duct can get so hot that tenants are expected to keep an 18-inch clearance, for the life of the building, by the way, as part of an occupancy's smoke control system. Code intent based on E119 conditions of acceptance for non-load-bearing walls also cannot be to substitute testing changes of duct direction between the horizontal and vertical planes, which is mandatory for electrical fireproofing, with T connections to nowhere. The presenter, that would be me, is not a lawyer. I'm not. These are merely search results for consideration in approving alternatives to shafts based on ISO 6944 and or ASTM E2816 fire testing. Users of this information are encouraged to order and read the applicable test standards and make their own determinations. Look at where the thermocouples are and what data you're getting. So we'll begin with U.S. law. Title 15 of U.S. Code, paragraph 45, unfair methods of competition. Now, why would there be anything unfair? Unfair because code intent is systems that meet the conditions of acceptance for non-load bearing walls under ASTM E119 or UL263 or CAN ULCS 101. So I'm presenting something that may be like an inch and a half thick or something against, let's say, a 2-hour rated system, regardless of what it's made out of, right? Concrete, block, drywall, what have you. Under paragraph A here, declaration of unlawfulness, power to prohibit unfair practices. So is it possible for this to be viewed as unfair against what the code intent is? That's the question, right? Inapplicability to foreign trade. Unfair methods of competition in or affecting commerce and unfair or deceptive acts or practices. That's the question. Is the legal question to pose is the representation of test results to E2816 and ISO 6944, test results that apply to a through penetration fire stop, a minuscule portion of such ductwork where it pops through rated walls and floors, to present those results in a way that can be misconstrued as meeting code intent. Can that be considered a deceptive act in accordance with Title 15 of U.S. Code, paragraph 45? Again, that is the question. The defense against it, I imagine, would be, well, we tested it to a national standard. It's an accredited standard. Okay, who's on the task group? Who's actually working on this? Who's driving this? Right? Who are the members? Right? And that's something that can be subpoenaed. Right? I'd say follow the money, possibly. You know. For the purposes of this subject, is under A again. The term unfair or deceptive acts or practices include such acts or practices involving foreign commerce that cause or are likely to cause reasonable foreseeable injury within the United States, or involve material conduct occurring within the United States. Right. So that's the question. Is this creating false papers and writings within the United States in order to then present something that is less than what the code intent is that considered an unfair or deceptive act, unfair or deceptive practices? All remedies available to the Commission, that's the Federal Trade Commission, with respect to unfair and deceptive acts or practices shall be available for acts and practices described in this paragraph, including restitution to domestic or foreign victims. Those are the questions there for Title 15, paragraph 45. Title 18 of U.S. Code, Chapter 47. Except as otherwise prohibited in this section, whoever in any matter within the jurisdiction of the executive, legislative, or judicial branch of the government of the United States knowingly and willfully, 1. Falsifies, conceals, or covers up by any trick, scheme, or device a material fact. 2. Makes any materially false, fictitious, or fraudulent statement or representation. Or 3. Makes or uses any false writing or document knowing the same to contain any materially false, fictitious, or fraudulent statement or entry. shall be fined under this title, imprisoned not more than 5 years, or if the offense involves international or domestic terrorism, 8 years, yada, yada, yada. So, again, the same question. It's all the same theme. You know, misrepresenting test results. Testing a fire stop, but presenting it in such a manner that it could be construed as meeting code intent for shafts, as though a fireproofed duct qualified to ISO 6944 1985 or ASTM E2816, or even if you tested it to the 2008 version or the latest European standard for that matter. But presenting test results for ductwork based upon the minuscule portion, which is the through penetration fire stops, as opposed to the, yards and yards of lineal ductwork traversing a building. Right? That's the question. Does it fit into any of these under Title 18, Chapter 47? That's the question. Again, the defense against it would be, no, I've tested to these standards, and these are the results in accordance with the standard. The counterpoint is, okay, you know what code intent is. Was there an effort to bring out a standard that enables a lesser product to be delivered that doesn't actually provide the life safety function? Because that's the purpose of the code, is life safety. Right? Is this something that fits under this? Right? Am I creating false writings and papers? Is it a trick or a scheme, right, to for an act that would be covered by Title 18, Chapter 47? Okay, still Title 18 of U.S. Code, Paragraph 1002, possession of false papers to defraud the United States. I imagine this would be if you're selling to the United States government, so if it's a federal building. Whoever knowingly and with intent to defraud the United States or any agency thereof possesses any false, altered, forged, or counterfeited writing or document for the purpose of enabling another to obtain from the United States or from any agency, officer, or agent thereof any sum of money shall be fined under this title or imprisoned for not more than 5 years or both. Same Title 18, Paragraph 1018, official writings or certificates. Whoever, being a public officer or other person authorized by any law of the United States to make or give a certificate or other writing, knowingly makes and delivers as true such a certificate or writing containing any statement which he knows to be false, in a case where the punishment thereof is not elsewhere expressly provided by law, shall be fined under this title or imprisoned for not more than 1 year or both. So that's the question. You have a national standard of America. It's accredited, I believe, by ANSI. And you have an international standard, ISO, from 1985. And you're presenting test results as per those standards. And there's nothing false about that, right? The question is the misconstruction of the test results as being in compliance with code intent for shafts. That's the question, right? Because a wall system or floor system, combination thereof, tested to E119 or UL263 or S101, the fire doesn't get through, the heat doesn't get through, the hose stream doesn't get through. Right? So, and in here, it doesn't fall apart at the end. It can't all fall apart. The engulfment sample, that's great, but you don't know what's happening on the inside of the duct. You only know what's happening on the other side of the fire stop, outside the furnace, but you've no clue what happens with the fan because you have elected not to put any thermocouples on the inside. And by the way, there was an effort to, there was a work item within ASTM to make changes to that effect, but it failed. The only thing that had support within ASTM, and those records can be subpoenaed, right? Who brought forth what and so forth. You know, these are things that that are obtainable by law enforcement. So that's the question. If you're are you creating a standard collectively that then that then results in test reports and certification listings that are misconstrued to provide a life safety function in a building, to provide fresh, cool, breathable air to victims of a fire inside of a building. They want to be able to egress and breathe, or they want to be able to hunker down in an area of refuge and breathe. Not with superheated gases or, you know, or just be there and nothing arrives because the fan is toast because the fire happened to be outside of the portion of the duct where the fan was located, right? And the standards don't talk about the fans, but that's the purpose of the whole thing. It's the purpose of the whole thing, and it's impossible to not know that. If you're in that business, you know about that. It's called a pressurization duct system, or it's a smoke exhaust duct system, which, you know, that doesn't happen. Or let's get a little more sinister. This same thing has been used at times to fireproof oil lines. Okay, piping with oil running between an oil tank and a furnace. And then, oh, it's rated to ISO 6944, and under the alternates deal, you know, this got approved, right? The legal question here is, does this fall under the definition of possession of false papers and creating official certificates or writings, such as certification listings? The legal question is, does it fall into this definition? Could a case be made here? The defense is always the same, I imagine. No, I mean, here was a standard. I don't write the standard. I'm a manufacturer. I tested to the standard. Here are my results. Leave me alone, right? That's the defense, right? But who is putting all that together? Who's putting the standards together? Who stands to gain? Where does the money go? And so forth. By extension, accepting this when, on the part of a code official or an authority having jurisdiction, if you're accepting this, but these test standards are public domain. So you need to think about it from that perspective as well, and it would be the same defense. Well, no, it's a standard, it's nationally accredited, I presume it's okay. So you don't trouble yourself to look at where the thermocouples are and just exactly what is hosed. You know, you're okay with having the fan die within minutes? Those are the questions. Does it fall under paragraph 1002 or 1018 in terms of these test results or certifications? That's the question. 18 U.S. Code paragraph 1031, major fraud against the United States. So if you look at the very bottom line, $1 million. If you sold duct fireproofing or fireproof ductwork to Uncle Sam at a value of $1 million or more, I'm not sure if that would be just material sale or the installed price. No idea, but it would have to be a pretty big job. But if there were such a big job, then Uncle Sam may have some recourse under paragraph 101 of Title 18. Whoever knowingly, that's if these definitions fit. And I don't know that since I'm not a lawyer, but So whoever knowingly executes or attempts to execute any scheme or artifice with the intent, one, to defraud the United States or to obtain money or property by means of a false or fraudulent pretenses, representations, or promises. So same question as before, making the case that testing based upon the fire stop portion of a test and then having it applied to the whole ductwork system, does that fall under false pretenses? And if it was worth $1 million or more sold to Uncle Sam, would that be something that DOJ would look at under paragraph 1031 is the question. Okay, Title 18, paragraph 1343 is wire fraud. I think there's a parallel one that if you sent information such as this by mail, then it's mail fraud. But if it, website, email, fraud by wire, radio, or television. Whoever having devised or intended to devise any scheme or artifice to defraud, or for obtaining money or property by means of false or fraudulent pretenses, representations, or promises, transmits or causes to be transmitted, like getting a distributor to send information. Transmitted by means of wire, radio, or television communication in interstate or foreign commerce, any writing, signs, signals, pictures, or sounds for the purpose of executing such scheme or artifice shall be fined under this title or imprisoned not more than 20 years or both. If the violation occurs in relation to or involving any benefit authorized, transported, transmitted, transferred, dispersed, or paid in connection with a presidentially declared major disaster or emergency, as those terms are defined in Section 102 of the Robert T. Stafford Disaster Relief and Emergency Assistance Act, 42 U.S. Code 5122, or affects financial institutions, such persons shall be fined not more than $1 million or imprisoned not more than 30 years or both. So again, this is the question: is the representation of test results per ASTM E2816 or ISO 6944 that is obtained, information obtained by testing the fire stop portion of a duct system as opposed to the whole engulfment test, right? Is that does that constitute fraud according to paragraph 1343 of Title 18 of U.S. Code? That is the question. Okay, I'm not going to read all this, but Title 31 of U.S. Code, paragraph 3729, we're talking about the False Claims Act, and it's the same thing. It's selling to Uncle Sam. In this particular case, it's kind of unique in U.S. law. I believe that if there's a whistleblower, he or she can get some costs covered as a result of a successful prosecution. But it's the same as the other laws. We basically don't make false claims about your goods and services. And the legal question is, when you're reading Title 31, paragraph 3729, whether claims concerning the testing of systems to ISO 6944, 1985, and ASTM E2816, whether that if you're creating a situation where that can be misconstrued as being applicable to the whole pressurization duct system. Question is, does that fall under, when you're selling to Uncle Sam, under Title 31, paragraph 3729? That's the question. Okay, so much for federal criminal law in the United States. Now there's tort law. I'm not going to read it all, but basically this is where it would be one party against another, and it's typically fighting about money. And the idea here, the overriding theme, is negligence, right? And also with this, with civil proceedings, a percentage of fault can be assigned, and they call that joint and several liability. So, example, if the amount being argued over is $1,000, but somebody is 50% responsible, and he's got to pay 500 in damages. That's the concept behind that. Whereas under criminal law, everything must be proven beyond the shadow of a doubt, and it's all or nothing. So the United States generally recognizes 4 elements to a negligence action: duty, breach, proximate causation, and injury. A plaintiff who makes a negligence claim must prove all 4 elements of negligence in order to win his or her case. Right? And I got this from Cornell. Failure to behave with a level of care that someone of ordinary prudence would have exercised under the same circumstances. Right? So that's the question here, right? So if let's say the person being sued were a manufacturer, he or she were making duct fireproofing or fire resistive ducts, and tested this to ISO 6944 or ASTM E2816. Is it reasonable that these folks would know that the pressurization fan is located inside that ductwork? If it is, and it can be proven that they know that the heat inside of that duct would be in excess of what's covered under the conditions of acceptance for ASTM E119 and UL 263 CAN ULCS 101, that would be exceeded, meaning a clear and present danger for life safety in the building, being that the purpose of the pressurization ductwork is to enable people to breathe as they egress or hunker down until rescued, right? And to misconstrue test results, to make a sale on the basis of, oh, this is fitness for purpose for pressurization ductwork, right? The legal question would then be, could that be deemed negligible, right? That's the question. And the defense is crystal clear. No, I just provide the test results. It's a an accredited standard and so forth. And the counterpoint remains the same. Who all put it together, right? If you attend ASTM meetings, as an example, you've got folks who have a vested interest typically in the outcome of a standard. It's under consideration, whether it's a new one or changes to one, and those are typically the folks who argue for or against contents, and then you've got folks who don't have, let's say, a horse in the race, and wherein lies the responsibility, as these things are put together, right? Is there a trade association that has substantial or material input in it, right? And if those folks are on the same page, right, these would be competitors, and not all competitors are on the same page all the time, but perhaps some of them are. Those are the things that would be gotten into, I imagine, if there were civil proceedings along those lines. So those 4 items are important: duty, breach, proximate causation, and injury. And is it neglectful? Would the party being sued, can that party be reasonably anticipated to know the purpose of a pressurization duct, right? Or are they purposely avoiding the use of that term and talking about HVAC, much broader term, and duct A, B, C, D, instead of calling the child by name? What is it used for in a building? Because you're not selling it to go out into the woods. It's in a building. It has a purpose. It's pressurization ductwork. Can it be successfully argued in a court of law that the person who helps to put the standard together, who then creates marketing and advertising information and so forth, and then and then relies on others. Well, hey, it's not me; it's the code officials. Right? So, to what extent do the code officials have a problem? Right? I mean, everybody always tries to deflect liability, right? So that's why we have courts, and that's how it works anyway. So there's the entry into U.S. tort law having to do with negligence, where this is concerned. Just finishing up the U.S. tort law here, determining a breach created by a judge learned hand in United States versus Carroll Towing. If B is less than PL, then there will be negligence liability for the party with the burden of taking precautions. If the burden of taking the precautions is less than the probability of loss, L, gravity of loss, gravity of the personal loss, not social loss. Right? So the sort of a formula being applied to it under this particular precedent of U.S. versus Carroll Towing. If the burden of taking such precautions is less than the probability of injury multiplied by the gravity of any resulting injury, then the party with the burden of taking precautions will have some amount of liability, which again can be assigned by means of a percentage. Determining whether there was a duty to act. So, and determining whether there was an injury, right? And those are sort of self-explanatory. Would somebody providing a fireproof ductwork system have an obligation to inform the customers that there is inadequate insulation provided to safeguard the proper functioning of the fan? Right? If there were losses, injuries, casualties as a result. Those would be the types of things argued under tort law in the United States.
Okay, don't adjust your set. We're now going to switch to Canadian law.
Good day. How's it going? Okay. Boy, I don't know what's going on. Why the letters didn't come up?
The letters?
Yeah.
Oh, there they are.
Okay. Good day, welcome to the Great White North Canadian Corner. I'm Bob McKenzie, this is my brother Doug.
How's it going, eh?
And
So I don't know how many times you've heard, if you see something, say something. Well, Bill C-46, the Canadian Criminal Code, Section 21, codifies it. Right? Where two or more persons form an intention in common to carry out an unlawful purpose and to assist each other therein, and any of them in carrying out a common purpose commits an offense, each of them who knew or ought to have known that the commission of the offense would be a probable consequence of carrying out the common purpose is party to that offense. So everyone everyone is a party to an offense who A, actually commits it, B, does or omits to do anything for the purpose of aiding any person to commit it, or B, abets any person in committing it. Right? So even if you omit, if you know about it but you don't do anything about it, that's a problem in Canada. Section 22 of Bill C-46, Criminal Code of Canada. Counseling an offense, getting somebody else to do something. Where a person counsels another person to be a party to an offense, and that other person is afterwards a party to that offense, the person who is counseled is a party to that offense, notwithstanding that the offense was committed in a way different from that which was counseled. Heavy duty stuff. Then Section 380, that's sort of the center of the whole fraud deal under Canadian criminal law. So 380 and then in parentheses 1. Everyone who by deceit, falsehood, or other fraudulent means, whether or not it is a false pretense within the meaning of this act, defrauds the public or any person, whether ascertained or not, of any property, money, or valuable security or any service, is guilty of an indictable offense and liable to a term of imprisonment not exceeding 14 years, where the subject matter of the offense is a testamentary instrument or the value of the subject matter of the offense exceeds $5,000. So, sentencing aggravating circumstances. This is part of 380 fraud. Without limiting the generality of 718.2, where a court imposes a sentence for an offense referred to in section 380, 382, 382.1, or 400, it shall consider the following as aggravating circumstances. A, the magnitude, complexity, duration, or degree of planning of the fraud committed was significant. B, the offense adversely affected or had the potential to adversely affect the stability of the Canadian economy or financial system, or any financial market in Canada, or investor confidence in such a financial market. C, the offense involved a large number of victims, like buildings all over the place. In committing the offense, the offender took advantage of the high regard in which the offender was held in the community. E, the offender did not comply with a licensing requirement or professional standard that is normally applicable to the activity or conduct that forms the subject matter of the offense. And F, the offender concealed or destroyed record related to the fraud or to the disbursement of the proceeds of the fraud. Right? So, of course, one can argue against all of this, right? The magnitude, well, you've got a bunch of buildings. What's the magnitude, right? Complexity, well, we created a standard and tried for over a decade to get it into the code, and it just wouldn't make it in, so then I had to go through the alternative process to get it into buildings. The duration or degree of planning, it speaks for itself with what's been discussed here, right? And whether or not it's applicable, whether or not it's illegal, it's not for me to say. That would be, I'm just pointing out Google search results here. The offense was adversely affected or had the potential to adversely affect the stability of the Canadian economy. Well, if it were a very high-profile occupancy, let's say, if it were used somehow in critical national infrastructure, a command center, a big hospital, important people in it at the time, I don't know, financial market, I don't know, stock exchange, building, whatever. The offense involved a large number of victims. Well, this has been sold for quite some time now, and it's in a whole lot of buildings. The offender did not comply with a licensing requirement or see the E. I could see an attorney jumping all over this to say, this is not, this doesn't apply, but does it? I mean, I'm creating a professional standard for the purpose of what? That's where the arguments would go back and forth in front of a judge if it came to a case. Concealing or destroying records, I don't know. Would it be a concealment to say that there's a whole bunch of communication at the ASTM E2816 committee, trying to get an item in there to change the standard to address these fallacies, of protecting the fan, of providing a greater level of fire protection that is equal to or better than the conditions of acceptance of E119 for a non-load bearing wall. These are the questions that would be discussed under any proceedings that would be involved here. This section of the criminal code, section 436, is called arson by negligence, and it goes a step further than building or fire codes in that it discusses damage to property as well. So here it goes. Every person who owns in whole or in part or controls property is guilty of an indictable offense and liable to imprisonment for a term not exceeding 5 years, where as a result of a marked departure from the standard of care that a reasonably prudent person would use to prevent or control the spread of fires or to prevent explosions, that person is a cause of a fire or explosion in that property that causes bodily harm to another person or damage to property. Damage to property is therefore codified when it comes to fire issues, and so arson by negligence. That goes above and beyond building and fire codes where it goes into property. The very first part, though, would be the first to be attacked in defending against any charges having to do with this. Every person who owns in whole or in part or controls property is guilty of an indictable offense and so forth. So the defense against that by manufacturer, contractor, distributor, anybody involved with getting a system into a building that is afterwards judged to be done under false pretenses, hypothetically speaking, right? If that had been established, that the lack of protection of the fan that people ought reasonably to know is inside the ductwork. If that were established, that everybody involved with it ought reasonably to have known about this, then it's especially for folks who buy the fans and install them on their shop floors into the fire-resistive ductwork systems. Right? Obviously, they know. If they know how much heat goes through, how quickly, then by virtue of having that on their shop floors, they know. Then folks who sell insulation or other stuff through distribution, and I guess they could argue, well, we didn't know. Well, a lot of you guys go on construction sites. You know this. You've seen the plans. You know where the fans are. It's very difficult to argue your way out of if you know anything whatsoever about construction. So, anyway, this first part here, every person who owns in whole or in part or controls, and that's crucial here, controls property. Why is that of interest? Here's why. Okay, a building is being built. A contract is let to the sheet metal contractor, right? And I'm using real construction terminology. It's the sheet metal contractor, and he typically works for the mechanical contractor, right? We don't say HVAC, this is non-construction terminology to me. Who controls the property when the fireproofed ductwork system forms part of the building? Once it's in the building, it belongs to the owner once it's all paid for. But the fact of the matter is that there is a time during which the manufacturer of the fireproofing and or the ductwork has control of the property. He's got an order. It's under his control, his or her control. It's then sent to the site. It is then installed, and it is paid for in installments, in monthly progress billings from the contractor, right? And the contractor also receives the goods maybe from the distributor, maybe from the manufacturer, and there's a time span where, okay, the products are shipped, then they're received, an invoice is written, and it is paid at some point later down the line. So the folks in the supply chain have control of the property that is going into that building for a period of time. So to me, not being a lawyer, right, I'm not trying to give anybody legal advice, but that's how if I were the one who says, hey, somebody else is responsible, if I'm making a claim, then I would use that here. Every person who owns in whole or in part or controls property. This not necessarily the super of the building, but it could be a vendor who is being paid in progress payments, and he doesn't get his final money until the 10% holdback is released, when everything is approved and everything else, and then everybody gets paid and done. Otherwise, people start leaning the building, right? So the owner of the building doesn't have full control over every aspect of what goes into that building unless and until the last dime has been paid on it. So before that, vendors, contractors, and so forth can be argued, I believe, to have had control over this property for that period of time. So very important aspect under arson by negligence. Okay, this is the last one now. Looking at the Canadian Competition Act, Section 7.1, Deceptive Marketing Practices. Reviewable matters, reviewable by whom? That would be the Competition Bureau, which is part of Industry Canada. Permitted representations, indications, right? It includes, let's see, for greater certainty in the section and in those sections, blah, 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 the making or sending of a representation includes permitting a representation to be made or sent, right? So, same as in the States, causing somebody else to make a representation. Representations accompanying products. For the purpose of this section, a representation that is expressed on an in-store or other point of purchase display, made in the course of in-store or door-to-door selling to a person as ultimate user, or by communicating orally, or by any means of telecommunication. Would be on the web as well. Email, phone calls, to a person as ultimate user, or contained in or on anything that is sold, sent, delivered, transmitted, or made available in any other manner to a member of the public, is deemed to be made to the public by and only by the person who causes the representation to be so expressed, made, or contained, subject to subsection 2.1. Now, what is a representation to the public? Number 3, it's the last paragraph here at the bottom. Subject to subsection 2, a person who, for the purpose of promoting directly or indirectly the supply or use of a product or any business interest, supplies to a wholesaler, retailer, or other distributor of a product any material or thing that contains a representation of a nature referred to in subsection 1 is deemed to have made that representation to the public. Again, this is part of the Competition Act, Section 7.1. General impression to be considered. In a prosecution for contravention of this section, the general impression conveyed by a representation, as well as its literal meaning, shall be taken into account in determining whether or not the representation is false or misleading in any material respect. There are parts to this, but I think it's self-explanatory, right? It's not just the literal word that you're writing or saying, it is the general impression as well that is considered in a potential prosecution under this section. And that's the last of it. Misrepresentations to the public. Right? A person engages in reviewable conduct who, for the purpose of promoting directly or indirectly the supply or use of a product, or for the purpose of promoting directly or indirectly any business interest by any means whatsoever, you're making a representation to the public. You can get into this further if you like. You can download the acts, Canadian acts. You can download the U.S. code and so forth. Again, I'm not an attorney, but if you were to ask me what would be the potential exposures if there were a claim, if there were something before a court of law, I suspect that these items here would come into question. And that's it. Thanks for watching. I know this is kind of long, but these are the various moving parts and pieces that are at issue with this topic. In general, I wish, instead of just manufacturers, when it comes to standards writing, I wish that cities were represented, counties, authorities having jurisdiction, building inspectors, fire prevention officers. What we get in standards meetings where these standards are put together are representatives of companies that have a bottom line responsibility. And that is the primary motivating factor for those good folks. That's not good, bad, or indifferent. It just is the way that it is. If we had a fire prevention officer or two in there, a building inspector, these folks are motivated by life safety. And it's just a different motivating factor when assembling documents of this nature. We have lots of those good folks when it comes to code hearings, right? At ICC, no problem. It's full of inspectors and so forth, and folks of good intentions, and they're the ones who get to vote on code change proposals. But we really, really need some of those good folks at ASTM E2816 and other such committees where safety standards are being discussed and evaluated and passed and made into official documents. Because somebody has to speak out for public safety, where the public safety is the primary motivation as opposed to just a bottom line responsibility. Because that has an effect, and the trouble is getting those folks to be funded to come out and take part in these meetings, which then go into codes and can have a really big effect. So again, I'm simply providing information for my intended audience here of code officials, of building inspectors, fire prevention officers, and I'm suggesting strongly that don't just rely on, look at this as a hint, and dig up the information yourself, buy the standards, look at what's actually in there, and look at the various disclaimers and so forth, so that if you are permitting an alternate to the code on the premise of meeting code intent, that you actually know what it is that you're doing. Because I think that oftentimes you don't. Thank you.